All right, let's look at the Pythagorean theorem. So we've certainly talked about this before. We used it to find the distance between 2 points, a long time ago. But we know the Pythagorean theorem says that if you have a right triangle, and a right triangle is a 90-degree angle here, that if we have a right triangle, then we know that a squared plus b squared equals c squared. So if we have a right triangle, we know that if we square the legs and add them together, that equals the hypotenuse squared. A and B are the legs of the triangle, which are the two smaller sides, and C is the hypotenuse. The hypotenuse is for sure always the longest side. It doesn't really matter how it's oriented, but the longest side, the hypotenuse, is across from the right angle. And it really allows us to do, really just two types of questions. Oops, I meant to write that. So, both of these triangles are right triangles. In this case, I know both legs, and I want to find the hypotenuse. Again, I know I can use the Pythagorean theorem, meaning I know this is true because I have a right triangle. Since this is a right triangle, I can write 2 squared plus 4 squared equals x squared. That's 4. 16 equals x squared. That's 20 equals x squared, and then I'm going to take a square root of both sides. So x equals the square root of 20. And on the previous lesson, we learned that we could write the square root of 20 as 4 times 5. And so then we can reduce that and say that x is 2 radical 5. Now, if we wanted it as a decimal, we just get out a calculator and take 20 and take the square root of it, and we get 4.47. 4.47. Again, that's the approximation. The exact answer is 2 radical 5. The approximation as a decimal is 4.47. Okay? Now, in this case, I have a right triangle, so I can use the Pythagorean theorem, and I don't know one of the legs. It doesn't really matter. That's not really A or B. They're just both the legs. So I can say that 5 squared plus y squared equals 10 squared. So that's 25 y squared 100, and then I'm going to say y squared equals 75, right? I'm going to subtract the 25 over, and then y equals the square root of 75. You're like, oh, but remember, I can write 75 as 25 and 3, and I can take the square root of 25 and get 5. So 5 radical 3. Now, if I wanted that on the calculator, I could have just stopped at 75 and just taken the square root of 75 and got an 8.66. Okay, so approximately 8.66. Lots of times when we do story problems, we'll change it to a decimal, but when we're doing math questions, these are really the acceptable answers for x and y in that case. Okay, so that's really the two main uses of the Pythagorean theorem. Of course, is just to solve for a missing side, whether the missing side is the hypotenuse, like in this example, or the leg in this example. Okay, now let's go over to here, and remember, Pythagorean triples. Triples are specific examples of the Pythagorean theorem where all 3 sides are integers. And there's an infinite number of them, but you just can't pick anything you want. For instance, if you use 2 and 4 as the legs, you don't end up with an integer hypotenuse. You end up with exactly 2 radical 5, which is, close to 4.5, but it's not an integer. If you do a 5 and a 10 and the other leg, well, it's this. It's not an integer. These are not triples, right? A triple is a situation in which all 3, the 2 legs, and the hypotenuse are all 3 integers. And the 2 most popular ones are the 3, 4, 5 triangle and the 5, 12, 13 triangle. And then these are like the cousins, right? And we already did similar triangles. So if 3, 4, 5 is a triple, well then 6, 8, 10 is a triple because it's just a scale factor of 2. Well, then the 9, 12, 15, the 12, 15, 20, they're all Pythagorean triples. This is all the same family, the 3, 4, 5. 300, 400, 500. 30, 40, 50. It can be anything I want it to be. 33, 44, 55. I can scale that up as much as I want. The same thing here. If the 5, 12, 13 is a triple, wait a second. How do I know it's a triple? Well, I could check, right? Couldn't I just check to make sure that 5 squared plus 12 squared does in fact equal 13 squared, and boom, 25 plus 144 does equal 169. Of course it's a triple. Here's some less popular ones. I just chucked them in there. The 7, 24, 25 is a triple, the 9, 40, 41 is a triple, 36, 323, and 325 is a triple, and so on. The cool part, again, don't need to know this, just thought it was kind of cool to throw it out there. You can actually construct any one you want. You can have there are an infinite number of Pythagorean triples, and these are kind of ways. You can pick any m and n integers. M and n are integers. And then this actually spits out a Pythagorean triple with A, B, and C based on these formulas. Again, this is maybe kind of a bonus type idea, but you have to know that there are triples and that you know what a triple is, and you should be able to know the popular ones, the 3, 4, 5, the 5, 12, 13, and maybe you know these are kind of your most popular ones. Okay. All right. How about applications of the Pythagorean theorem? So I just kind of picked 3. There are obviously a ton of different story problems we can do, but how about this one? How about I give you a rectangle and you know that this length, so like the length is 15 and the diagonal is 20. Can you use those two pieces of information and find the perimeter and area of the rectangle? You're like, well, it is a rectangle. So since it's a rectangle, you do actually know that that's a right angle. But if that's a right angle, then you know the Pythagorean theorem is true. Well, then I can find that length. So I can say 15 squared plus x squared equals 20 squared. So that's 225 plus x squared equals 400. Okay, so then that's x squared equals 175. And then since this is a story problem, you know what? Let's just keep it as that. All right, so the square root of 175 as a decimal, if we wanted it to be, it would be like 13.22, 13.23 if we wanted it as a decimal. If we wanted it exact, we'd say, well, that's just 25 times 7, so it would be 5 radical 7. Okay, so now that I know, let's you know what, since it's a story problem, let's go ahead and use this as our x. So once we know 3.23 is x, well then the perimeter is just the distance around, right? The perimeter we know is just twice the length and twice the width. So that'd be 2 15s and 2 13.23s. So we just do 2 times 15, 2 times 15 plus 2 times 13.23. And we get a perimeter of 56.46 inches. Area is just length times width. So that would just be 15 times that 13.23. So 15 times 13.23. So it'd be like 198.45. And that would be in square inches, of course, its area. Okay, so that's one of the applications. We can work with diagonals and perimeters and areas of rectangles and such. Okay, how about this one? You're out flying a kite, and you know the kite is 20 feet away from you on the ground, so it's kind of the ground distance, and you've let out 50 feet of string. How high is the kite, right? So you're gonna solve for h. Well, you know that the kite vertically does form a right angle, so then you can use the Pythagorean theorem. You can say, well, 20 squared plus h squared has to equal 50 squared. So that's 400 plus h squared equals 2500, right? 50 squared. And then we get h squared equals 2100. And then h equals the square root of 2100. And again, most story problems we are going to treat and get a decimal. So 45.82. 45.83 actually, and that would be in feet. So if you know how far the kite is on the ground and you know that kite string length, you bought a kite and it says it's got 50 feet of string, you can tell me exactly how high it is, again, using the Pythagorean theorem because I have a right triangle. All right, down here, let's say I have two cities and they're on a map, and you know the coordinates of these. And again, we did this a lot earlier. We can find those two distances. This is 5, 3, and this is 11 and 14. So 5 to 11, that distance is 6 over, and then 3 to 14 is 11. So I'm going 6 over and 11 up, and I know they form a right angle, which then I know the Pythagorean theorem is true. So then the distance is 6 squared plus 11 squared equals, we'll call it a d squared, whatever. Okay, so that's 36 plus 121 equals d squared. So that's what? 157 equals d squared. So d equals the square root of 157. You're like, oh, 157. Does anything go into 157? And you're like, oh, I don't actually know. Doesn't seem like it. Let's just treat it as, 157. Let's just figure it out as a decimal. I don't think actually it simplifies, and we get somewhere around 12.53. Actually really close to that. And everything is in miles, let's say. So it would be that miles away if those are like two cities. Okay, so use the Pythagorean theorem when you have right triangles. We can use it for a variety of cases. These are just kind of 3 different story problems. You do not need to memorize all of the triples. You don't need to even memorize the formula to make the triples. I just thought that was kind of fun to do that. Certainly finding a hypotenuse or finding a missing leg is the key. And again, the Pythagorean theorem has 1,000 proofs, and I probably will attach another video to Canvas where it kind of has some fun ways to prove the Pythagorean theorem is true, but this is kind of how you use it.